Hello? Is this on? Can you hear me? I would have a professor do that every day when he recorded his lessons in class. And then he would chuckle. Anyways, so I've got an example with using the fundamental identities. Now, when you did the simplify, the verify, the matching a couple weeks back, that's basically what you're doing here. You just have to recognize the situation when an identity is needed. And right now, these are just the basic fundamental identities. The formula identity, the formula sheet identities will be a couple of weeks in the future. So you kind of have to recognize, so one, anytime you've got a square term, maybe there's an identity. The clue for the fundamental is that you've got a square term with one trig function and you have a not square term with another trig function. Now there are different characteristics. So like you might also use the reciprocal identities or quotient identities or negative angle identities. So you have to be aware of that situation. Now, I got my thinking over here because my brain still doesn't connect. Is it tangent and cosecant and I'm not sure. So I start with the basic Pythagorean, sine squared plus cosine squared equals 1. I want tangent, so I know to divide by cosine. So sine over cosine tangent, cosine cosine 1, and then 1 over cosine secant. And then I go, oh, now I know what. So first thing I do, of course, is move everything to the left side so it's equal to 0. That's always a good first step. And then this kind of looks like the quadratic form, right? We've got something squared, we've got something not squared, and we've got a third thing that's just a number. So, but they're different trig identities, and that's where they're different trig functions. That's where the identity comes in. So I substitute tangent squared to be secant squared minus 1, combine the minus 1s into minus 2, factor it, set equal to 0, solve them like that. And these are still the unit circle angles and numbers. So cosine is a half, it's positive, so quadrant 1 and 2. That's the small number 1/2, so it gets the large angle, pi over 3, 5 pi over 2. And then -1, cosine -1 is that. So you'll notice when I solved this with secant, and then I flipped it over to use cosine, because I still have no clue about secant like that. The only other caution that I would offer, it doesn't happen here, but think about the functions that you have up here. And occasionally, if it's more complicated, so the tangent, cotangent, secant, cosecant all have angle values where they're undefined. So through the identity, so I'm using the Pythagorean identity up front, I've got a reciprocal identity at the end. You might have introduced an extra solution that's not valid for the original equation. So it's always good to double check that. Now, normally those only happen when you've got equal to 0, secant x equals 0, and you flip it over for cosine, that's not going to work. So just at the end, just think about it. Both of these, tangent and secant, are undefined where cosine is 0. So just think about that at the end when you get done, just in case. It doesn't always happen. It didn't happen here, but it might happen, just the process of what you've done there, like that. Okay, I'm done with this video. I may have another one, but I'm for the fundamental identities. But like I said, you've done all the simplify, verify, the matching assignments, so you're familiar with them. And then it's just algebra. Every time you do something new, it turns into an earlier thing that you've done.